Space is immensely vast, and it is estimated that there are about 100 billion stars in just the Milky Way galaxy. Each of these stars may have multiple planets, and among them, some planets might meet the conditions necessary for life to exist. With recent advancements in astronomy, many exoplanets have been discovered. Among these, some are located in the habitable zone, the region where liquid water can exist. The Kepler Space Telescope has discovered thousands of exoplanets, some of which have conditions similar to Earth. Let's assume there is an extraterrestrial civilization, ETC, in our Milky Way galaxy. Unsatisfied with the prosperity of their own planet alone, they plan to colonize the entire galaxy. How much time would be needed to achieve this plan? Let's introduce various hypotheses by scientists and experts on this question. Michael Hart's hypothesis. If the etc. sends colony ships to nearby stars at a speed of 0.1 c, 1/10 the speed of light, and sends out the next colony ship from the colony at the destination, this etc. will soon colonize the galaxy. If there is no delay before the next departure, the wave of migration will spread through the galaxy at a speed of 0.1 c. Even if the time between movements is the same as the time taken for navigation, it would spread at a speed of 0.05 c, taking about 600,000 to 1,200,000 years to travel from one end of the Milky Way to the other. Eric Jones's hypothesis analyzed a model where colonization is driven by population growth. Assuming a population growth rate of 3% per year and a colonization rate of 0.03% per year, the model showed that even a single etc. venturing into space could colonize the entire galaxy in 5 million years under these assumptions. If Michael Hart's and Eric Jones's hypotheses are roughly correct, then it wouldn't be surprising if an etc. had already come to us and revealed their presence. William I. Newman's and Carl Sagan's hypothesis argued that colonization of the entire galaxy cannot be driven by demands from population growth. Looking at humanity as an example, the world's population more than tripled in the 20th century. If the population continues to grow at that pace and we want to maintain the current population density of Earth, within a few hundred years, the wave of colonization would need to move at the speed of light. Once that point is reached, the population growth rate would have to decrease. Etc.s do not establish colonies as a means to avoid overpopulation of their home planet. In the long term, issues arising from exponentially increasing population cannot be avoided. In other words, they would not be able to move at the necessary speed. Civilizations must stop population growth regardless of whether they develop space travel. If etc.s implement a zero population growth rate, they would only just be able to reach Earth with a lifespan of 13 billion years. Bjork's hypothesis. Suppose an etc. decides to survey the galaxy as follows. They first send out 8 mothership probes, each equipped with 8 small probes to be used at their discretion. Each mothership is tasked with surveying a region containing 40,000 stars in the galaxy. The mothership travels to its destination star and releases the 8 small probes to survey still unexamined stars. The small probes travel at a speed of 0.1 c, conducting flyby surveys. If a probe detects intelligent life, it reports back to its home planet. If it detects nothing, it continues to move on to the next unexamined star. Once a probe visits all the designated 40,000 stars, it returns to the mothership, which then heads to a new destination star to repeat the survey. Using this method, only about 4% of the galaxy can be surveyed in roughly 300 million years. If these hypotheses are correct, the reason etc's haven't come to us yet could be that interstellar travel is slow and expensive, and not enough time has passed for them to reach us. It is estimated that our universe was born about 13.7 billion years ago. Given 13.7 billion years, it wouldn't be surprising if civilizations that are tens of thousands or even billions of years older than ours existed. Could it be that none of them reached the technological level necessary for space travel? They had tens of billions of years just to get here. So, why haven't we discovered any traces of them yet?